Hello, and welcome to Best Practices for Compliance for the Virginia Graeme Baker Pool and Spa Safety Act. My name is Steve Barnes, and I am Director of Science and Compliance for Aquastar Pool Products. I am also the Chairman of the VGBA 2017 Standard Writing Committee. And so let's jump right in. So we're talking about the Virginia Graeme Baker Pool and Spa Safety Act that was introduced by Congress in 2006 and passed in 2007 by President George W. Bush on December 19, 2007. It is designed to prevent the tragic and hidden from swimmers hazards associated with drain covers and suction outlet fitting assemblies. So the whole point of this standard in this presentation are to address all of those preventable tragedies and injuries. So what is the VGB Act? Let's take a quick look at the legal structure of it. It is U.S. federal law. You can see here, you can go look it up in 16 CFR Part 1450. That's where it's at. It is officially known as the Virginia Graeme Baker Pool and Spa Safety Act. The act itself has a lot of provisions dealing with grant programs and certainly suction safety and all kinds of things. But what we're going to focus on here is the fact that that law designates the drain cover standard as a U.S. consumer product safety standard. That's what puts the drain cover requirements into federal law. The full title of the current standard is ANSI APSP ICC-16, and it is the 2017 edition. The full title, American National Standard for Suction Outlet Fitting Assemblies, we call them SOFAs, for use in pools and spas and hot tubs and basically anywhere we have bather accessible recreational water, whatever the vessel may be. So let's talk about VGB Act enforcement. So the Act requires the U.S. Consumer Product Safety Commission to enforce the Act using money that they are allocated. The Act does not require state or local enforcement. It does not prevent state or local enforcement. And states and local jurisdictions can and do impose additional regulations. So practically speaking, certainly 100% for residential, but practically speaking on our public pool systems, it's going to be your local authority having jurisdiction who are going to review and check on compliance with the Act as it relates to the drain covers. So this is what the standard looks like. Virginia Graeme, it's the VGBA 2017 is how we refer to this. And as we discussed, it is a U.S. consumer product safety standard. So let's talk a little bit about the certification authority has changed slightly. I won't go into the backstory on that, but basically manufactured suction outlet fitting assemblies, those must be tested in an ISO 17025 certified test lab. So not just any lab, not just a nationally recognized test lab. It has to be a lab that is accredited to this ISO standard. After the testing, then the product, performance, documentation, certification, head loss curves, all of the kind of technical stuff that you're now seeing associated with these drain covers that is all reviewed and certified by an accredited certifying body. NSF, for example. IAPMO is another big certifying body. Those agencies are certified to 17065, so it's a little bit different. But this is new, and this is really what's kind of tightened up everything on the manufacturers and that kind of thing. So the act changed, or the standard changed, and there are some new requirements that we're going to go into. It's important to understand that existing product compliance, everything that is in compliance with the VGBA 2008, proper covers, proper installation, things aren't expired and all that, those are considered in compliance with this standard. And that's true of the drain covers in inventory, not that you can really find them now at this point, but anything that's in distribution, on shelves, and certainly anything installed in pools, all of that prior product is legal even after the standard went into effect. So that's an important thing to keep in mind. Just because the law changed doesn't mean we have to go back to the pools and replace those covers. What you're learning here today will take effect when it's time to replace those covers, and certainly for any new construction. So, why did it change? I think that was a question we were getting early on. Well, it is an American National Standards, American National Standard Institute, and their essential requirements require all ANSI standards to be reviewed every 5 years. And so basically that's what happened, and in that process there were some changes made to the standard. So now let's really focus on the meat of what this standard is all about and what's changed. And so the key thing is that there are new flow rate testing. So let's take a look at that. So the original standard, this goes all the way back to 1987, and this ponytail test you see is been in it from day one, if you will, and it was voluntary. This standard was voluntary until 2007, and so this ponytail is a wooden dowel, and it's 16 inches of human hair that is fed into the drain cover. This whole test lasts over 1.5 minutes. This is just the kind of the feed it into the drain cover part. Now, this test has to be conducted 10 times for every flow rating you see, whether it be floor, wall, different pipe sizes, all of that. So each drain cover has to pass this 10 times. In 2007, there was a new test added, and that's the body block test you see here. And it was specifically designed to address the fact that while the original 1987 standard talked about preventing body entrapment, there was no test for it. And that's why flat flush mount drain covers, just like the one Virginia Graham Baker was entrapped on in the spa, that was a certified cover to this standard. The standard didn't test, so it was flat in flush mount, 8-inch round. The other element about that drain cover is it had been in that spa for over 10 years, and while it looked okay, the sun degrades plastic, and so when we needed it most, it actually broke. So that's another change that came with the standard, is a life in years. And that has to be marked on all drain covers, because you can't tell that the plastic is getting brittle by looking at it from sunlight, chemicals, whatever causes those plastics to degrade. We can't see it. So that's why the life in years is so important. So with this test specifically, so it was intended to get rid of the flat ones. Well, it did. I'm sure you're well aware of that. And so you can see this test is performed with 120 pounds, so like an adult male laying down on a drain cover, in a shallow, shallow water area like a kiddie pool sort of a thing. So that's the rationale there. And then this test is done with the pump running at the maximum flow rate for whatever cover is being tested. And in this case, the pull force can't exceed 15 pounds. And by doing this, we're addressing the body entrapment hazard that existed prior to this test. It's the reason these covers stick up. It's also the reason why it's critically important that when you install drain covers, you must, critically important, use all the parts that come with it. In this example here, you kind of see two sets of holes. That's two sets of parts. You got to use all of them. These are a nuisance relative to stepping on them like in spas and shallow water, even play pools. And certainly the robot cleaners hate them because they tend to hang up on them. But never lose sight of safety is the most important thing. The other big change to the standard in 2007 was the introduction of this full head of hair test. So just like the original ponytail, it lasts for a minute and a half. The significance of this test is two things. One, the blonde hair is by design because that blonde hair tangles way easier than the brown hair for whatever reason, whether it be natural blonde hair we found or bleach blonde hair. Either way, for some reason, I don't know if it's thinner or what the case is, but it definitely tangles easier. So now this test has to be passed 10 times just like the ponytail. So it has to pass both of these at a flow rate that's 125% of what the cover will be rated for. This had a big impact on the smaller safety drains before the act, and the significance here is all of this hair plugs up smaller drains. So that's why some of the the leading safety drains early on were actually disqualified. Not disqualified. Their flow ratings lowered as a result of this test. So one of the biggest impacts, I would say, of the 2017 standard is now every pipe size must be tested. And this is true for any pipes that are within 16 inches of the surface of the pool, spa, wall, whatever. So we measure sump depth now from the surface of the pool down. And the reason pipes that are deeper than 16 inches don't have to be tested, but just one big pipe, is because the hair doesn't reach it. So whenever pipe is with less than 16 inches from the surface of the pool, then it's going to get a specific flow rate. Another, not a change, but one of the clarifications that was added to this standard is that, well, I guess it is a change, is they are marked blockable and unblockable. And there's a technical two-step process that determines that. It's, the sump opening and then the cover that's applied to it and the openings of the cover that are not shadowed by the blocking element. And then they must pass that physical test you saw. So there's, it's a two-step technical evaluation and then the physical testing. And the significance and why blockable versus unblockable is important is if it's a blockable drain cover like you see on the right here, then, if it's an existing pool, we need to do something about that with multiple drains or a suction vacuum release system, a suction limiting vent system, gravity drainage system, automatic pump shutoff. These are all secondary devices or systems to design suction, to prevent suction entrapment. And these are enumerated, listed in the Virginia Graeme Baker Pool and Spa Safety Act. And also in the act is when you have an unblockable, then you don't need, it can be single, and you don't need any of those secondary devices. So this is how we can know the drain cover in our hand, is it blockable or unblockable, so we know how to handle it relative to these issues. When we're talking about blockable drains, and this is certainly nothing new, but because blockable drains, we have to assume one is blocked, and then the flow rating of the whole system is based on that result. So in this example, a lot of numbers, but see if you can stay with me here. So let's assume we have a maximum system flow rate of 140 gallons a minute. That's when the high speed of a pump with 100% of the flow going to the drain system, so no skimmers, no gutter overflow kind of a thing. Let's hypothetically say that's 140 gallons a minute. The VGBA 2017 suction outlet fitting assembly flow rating for 2-inch pipe is 100 gallons a minute in this example. So the system is 2 100-gallon per minute drain covers, but so they add up to 200, but we assume one's blocked, so then the flow rate is 100. And the same applies to multiple drains. We're just going to assume one blockable drain is blocked. You subtract that flow rating from the set. So in this case, now let's talk about the compliance. So a 3-drain system, we assume one's blocked, the flow rating is 200. So now let's go back and look at the system compliance relative to our original 140 gallons a minute. So the dual drain system, even though the 2 drains add up to 100, the system's only rated for 100, so this would not pass that test. The 3-drain system does, because 2 of those drains added together is 200 gallons a minute, which is greater than our system flow rate. This is, it's easy to understand, but it's important to get it right. So not new, but it still remains very important. So you've heard me say suction outlet fitting assembly a couple of times now. It's in the title of the standard. So this is a change. They were originally called suction fittings. Well, suction fittings are skimmers, vac lock fittings where we connect our suction side cleaners, our manual cleaners, and all of that. Those are all suction outlets. Suction outlet is just water leaving a pool going to a pump. And so this clarifies that drain covers are, it's the whole, it's not just the cover, the top part you see here. It's all of the hardware, the rings, the sump, the pipe depth, and all of that. All of those things are what make up a suction outlet fitting assembly, and that combination, including pipe size, is what defines a specific model, and each model gets its own flow rate. So that's a clarification mainly. Now, one of the very big changes, other than having to test and give every pipe size its own flow rate, is the old figure 2, the 1.5 pipe diameters, has been removed from the standard. Okay, so this figure 2 field-built sump, it was never a requirement, and it was just an option for drain cover manufacturers that didn't design or sell sumps. So we had the safety drain covers and replacement drain covers that had never been tested, and so there was no minimum pipe depth. So that was the purpose of the original figure 2. So what has changed is now the sump design, pipe size, pipe depth determine the suction outlet fitting assembly's flow rating. So because of that, we can't use a generic 1.5 pipe diameters. The cover manufacturer, who has to have all the product tested and certified, must provide the sump depth details. So as installers and inspectors, we know that every drain cover is compatible with where it's being installed. So this figure 2 sumps can be and are certainly still used, but the manufacturer will have to test over them before you can use it. It's just not a rule of thumb that can be applied. So if the drain cover has been tested at 2 times the pipe diameter, then this doesn't apply at all. So the bottom line, what's really important is to follow the drain cover manufacturer's specifications, so you select and buy the correct product, and then make sure it's installed properly. So there are some minimum dimensions that manufacturer's instructions or specifications need to provide. And it doesn't matter whether it's a manufactured sump, like the sofa vinyl liner one that was in the definition of suction outlet fitting assembly. So that's a manufactured sump that comes with it. It can also be a field built formed in concrete. And so, we see this out west all the time, okay? So this is, so if a drain cover is tested over this shallow sump, it can be used on this sump or a deeper plastic one also. So the law allows for either. The key is to measure the sump. Doesn't matter what the water's touching. Okay, so another important change, helpful change, is there are new instructions required. And so the critical thing we've been talking about already is the minimum pipe depth dimensions. Now, one of the things to be aware of is we refer to this as sump depth, but sump depth technically means the bottom of that sump bucket. And if you have a side port, the depth of the bucket, is at the bottom of the pipe. So when you hear sump depth, think pipe depth. And so that needs to be documented. Winterizing instructions are now something that the manufacturer has to provide, and servicing, including how to check for infixed strip screws, for example. And their instructions may be, if this is stripped, replace the fitting or the mud frame or the sump or whatever the case may be. Other examples is you could use concrete anchors. I'll show some examples of that. Or it is possible to, if the sump or mud frame is designed for it and it's documented in the instructions, that you could drill out a hole and go to the next screw size bigger, for example. Very uncommon, but those changes, those kinds of things are allowed. And why it's important we have this flexibility as manufacturers in an industry is there's a lot of stuff out there that was, pre-1987, so there was no standard whatsoever. So the key here is follow the instructions. So there's been a fair amount of detail that I've given you here already that we've talked about, but now I want to kind of focus on the process of compliance or how we verify this. So these are the kind of the high-level key things you need. What is the sump opening size? In other words, is it an 8-inch, a 9-inch, a 18 by 18? What are we dealing with is step one, right? Now, what we need to know, the contractor is going to need to know, what is the pipe size under that cover and how deep is that pipe opening? Because that's the information the drain cover specifications will need to provide, so you know which cover to buy. This is real inconvenient for existing pools, understandable, because you don't know what you got until you go look at it, and which complicates the next thing is what is the actual flow rate of the system. Now that's assuming that we're looking at the skimmers and gutter overflow system is off, and what's the flow rate through the submerged suction outlet, when a variable speed pump is in high speed. So you need to think of flow rate as in terms what can actually happen in the pool. It might be, you know, we run for energy efficiency, the pool is running, you know, low and slow and doing a great job, but somebody can go boost that pump to full speed, like when there's a party and you have a pool full of kids, right? So we want to boost circulation and filtration and make sure we keep a sanitizer residual throughout the pool. That's the concern, is when the pump's running on high speed. So high level, what's the sump size? What's the pipe depth and pipe size? And then what is the system flow rate? Those are the three key things that you need to know for each pump's suction system. So let's talk about the existing installation fastener integrity. One of the most critical things is to make sure these covers are properly installed and in place. Missing broken covers are deadly dangerous. There is no backup for a missing cover. So the way we keep them secure from prying little kids' fingers and all of that is making sure the fastener integrity is there. Now, if we're talking new pools and new construction, new product, all of that's built in, easy peasy. But when we talk about existing pools, old spas, this is where the hazard exists and where the problem exists. So if you look here on the left, this is an existing manufactured sump that was actually, this is a photo of a wading pool where there was a tragic incident. So you can see, hopefully you can kind of see the screw holes. You know, this thing's been around for decades from the looks of it. And those screw holes were not, even though the correct screws that came with the cover were used, they had nothing to attach to. And so this is something that is being looked at by those certifying bodies. How do you address it? And so on the right is a retrofit and plate. There's no cover on it. You can see it's over an existing pool. This particular retrofit cover, and there's several, 5, 6, 7, or 8 in the marketplace, that you can use concrete screws. An alternative, and that's tested and approved. Another thing is there's a lot of covers that need only 2 fasteners, but they got 4, and you can see here there's, I don't know, 15 or 20 different screw holes. So it's possible you could rotate a cover. The 2 opposite each other are stripped out, but go 90 degrees and they're in good shape. So how do we know if that's authorized by a particular drain cover? The manufacturer needs to provide instructions. Now, here's a colorful example of some of those instructions. And if you look on the lower left, number 8 is, you know, it's completely stripped out is what we're showing there. Number 9 is it's an anchor or the frame or whatever that's stripped out. In the middle, number 10 is the threads are stripped out. So those are the kind of the 3 primary failure modes. And, you know, the one on the right is, you know, and it's good. And how do we, for these instructions, how do we know that? Well, you thread a screw in and you try and pull it out by hand and pull hard. But if you can't, no tools or any of that. If it's secure, then it'll hold down a drain cover, no problem. So obviously it's got to be the right number and all that. But the manufacturer's instructions will explain this, and it's important that you follow those instructions. So here's a look at kind of one of these universal drain covers that I mentioned that is designed and has instructions that support this. So there's really kind of 2 options here. So if you look at the green arrow on the left, it aligns with the 4 corners of this mud frame that's being installed in this existing pool. And you can see below in the lower right what's left of the circle mud frame. that came out of it, where they chipped it out and cut it out to install this 9x9 retrofit mud frame. So that's one option of this, but there is another with this particular cover, is it has extra holes out away from the 9x9 area, so it can be attached directly to a concrete pool with certified anchors, so that you have to get these concrete anchors from the cover manufacturer, or in the case of the rounds, they're included with it because this is kind of what they're designed for. In any case, it has to be authorized. Don't do it with just any willy-nilly drain cover. But in this case, they can use concrete anchors at the four corners, and they could have left that round mud ring in place because this cover is certified for that effect. And in fact, you can see that is the plastic sump there in the center. If you look carefully behind the green arrow on the left, that's that cover down in. This is over the top of that round sump. So it's tested this way, so it can be installed this way. These are universal covers that do this. The majority of the stuff of the covers in the market, including what we make at Aquastar, our 12x12s, or I don't want to use product names, but the point being is most of our stuff has to go on a mud frame. It's not retrofittable like this. So you need to pay attention. You can't just put any 12x12 or 9x9 and attach it with concrete anchors. It's got to be tested. So I mentioned this previously, but it's worth going into again, is manufactured and field-built sumps. Both are allowed. It's all about what is the pipe depth and pipe size below a cover. Beyond that any cover can be used over a manufactured or a field-built sump. It's all about the dimensions. Now, some covers just can't attach to anything but a manufactured sump. Prime example of that would be a portable electric spa hockey puck kind of fitting. Well, it's bolted to the fitting that's, bolted to the fiberglass shell, acrylic or whatever it's made out of. But when we're talking about, concrete pools and even existing vinyl liner and fiberglass, it's all about sump depth. If the cover's certified for it, you can use it. So, and what is a sump? Well, it's defined as the area below the cover, between the cover and the pipe, if you will. In this figure that you see here, that would be the kind of the B area, albeit there's a lot of other dimensions, E, D, C, and all of that. Those are required to be documented by the test lab, so we can validate how the cover was tested and certified, and it could be reproduced or whatever. Those are kind of a technical thing. What really matters for safety and making sure everything works as intended is going to be the pipe size A and then the pipe depth B, as shown here. And why this pipe depth and all this is important is because the hair can reach it. So you've seen this video before on the right. So that's 16 inches of hair being fed down slowly over the course of 30 seconds into the fitting. It's kind of hard to see in the video, but the hair actually goes down into the pipe. If you look at the center picture, you can see it definitely reaches the sump opening and can extend down that pipe. So on the left, you can see sump depth is measured from the surface of the pool or spa down to the pipe opening. So if it's a horizontal, you see you just hook the tape measure kind of thing. If the pipe comes in from the bottom or the back of the sump when it's installed on the wall, then you measure just to the top surface of the pipe. Another important aspect of this is this dimension F. So this is in the standard, and it's the minimum dimension before you can reduce the pipe size. And so the point is to make sure that where the hair can go into the pipe, that that pipe is a tested size and it doesn't get smaller than what's been tested. And so F is where you could switch pipe sizes. So you can see if where F is here, you know, the fitting to the right, if you will. Wish I could point at this, but that could be conceptually a T between dual drains. If this is 3-inch pipe, so you could use 3-inch pipe to get a nice high flow rate from a safety point of view, but reduce to 2-inch or 2.5 or something smaller to run back to the pump, because that's all we need for the specific system. So that's why this F is important, is, you know, we want really high flow rates for our suction system, and that is often achieved with big pipe that is much bigger than we need for proper hydraulics and design. So that's why F is important. The effect of sump depth, here's just kind of some look at some flow rates that the kinds of things we're seeing. So here's a 0 sump depth on a 3-inch pipe, and you can see that flow rate's 138 gallons a minute. With that same 3-inch pipe 3 inches deep, the flow rate goes up to 170 gallons a minute. The difference between the two flow ratings is how much hair goes into the pipe. And then here's an even deeper sump. In this case, it's the side port out. That's also 3-inch, and it has a flow rating of 250. Now, all of these flow rates are well above, well, certainly the 170 and the 250 for 3-inch pipe are well above what the system should be operating from a hydraulic design and building code on pipe velocity, line velocity limits, and all of that. The reason that drain covers are tested at the extreme is because, you know, skimmers can be plugged or turned off, or pumps run on high speed with all of the return side valves open. So like the spa and residential world, so the spa's running, the pool's running, and it's taking all the water out of one set of drains. That's the condition that we test for, so that no one ever gets hurt. So that's why the VGBA flow ratings are often 2, 3, 4 times higher than what you would ever want to design or operate a pool at. This is a red line safety. It's not a drive the speed limit issue. Moving into the differences. So how is these new flow rates being documented? The original VGBA 2008 standard required 2 flow ratings if a drain was rated for both the floor and the wall. It would have 2 flow ratings, one for the floor, one for the wall, and it would be marked on the drain cover. Now, debris removal drain covers, for example, a lot of those are floor only. Other, you know, skimmer fitting, you know, equalizer fittings or spa jet fittings often are wall only. So you got to pay attention to that too. They don't have to be rated for both. Under the new standard, we got multiple flow ratings, right? Lots of flow ratings. So the way that's handled is we now have a set of flow ratings for the floor, and that's based on each pipe size, each pipe orientation, and that pipe depth. The same applies for the wall. Same thing is each pipe size, pipe orientation, and pipe depth. And so it's the same fitting, just turned up on the wall. And now, because we have all these flow rates, instead of you know, putting a laundry list of flow rates, you're going to see 4 flow rating C instructions. So that's how that was handled because of all the new flow rates. Caution, caution, caution coming up here. Existing public pool compliance. Like for like replacements may not be VGBA 2017 compliant. Actually, I would say a majority are not going to qualify of like for like requirements because of all of these new pipe size, pipe depth, flow rates. Those changes are impacting. Now, instead of, you know, one flow rate for a fitting on the floor, there's going to be a bunch, and we have to know what those pipe sizes and pipe depths are. So the figure 2 sumps were deleted, remember, and replaced by tested sumps. So you can't have an engineer, for example, sign off on a hair test that's never been performed. Is the bottom line there. Is we can't, you can do the hydraulic engineering, and the body block is something that can be handled through math and, you know, advanced engineering skills, but there's no way to predict how hair is going to behave under each of all the various different covers. So they have to be tested. There's no way to sign off on those. The problem is now by using the maximum flow potential or the old flow ratings, it's going to cause smaller pipe size compliance failures. So if you use the end of the high-speed pump curve here, on this example, it's 175 gallons a minute. That's how that pump was certified to NSF 50, and there's a technical stuff that goes on there. But if we apply that to smaller pipe sizes that can't handle that flow, they appear to fail this standard. So if we look specifically at the building code limit for 1.5-inch pipe, it's 38 gallons a minute for residential, 50 gallons, I got that backwards, 38 gallons a minute for public pools, and 50 gallons a minute for residential pools. And if this pool has a variable speed pump installed, which is what's happening, right? And you look at the max flow of that pump, well, this system fails that test miserably on paper. The reality is you cannot get 175 gallons a minute through 1.5-inch pipe in the real world. We've come close in the lab, but even at that, it cavitates crazy in the test. So you just can't get there. So what we have to do for compliance is we got to know what is the actual operating flow rate. Now, here's a high-level way to do that. If you have a flow meter that's properly installed and is working properly, use that. That's your go-to. But when you don't know that, or you don't trust it, or you just want to verify, what you can do is use the pump's actual pump curve. And so the way to do that is you would measure the TDH on the vacuum and pressure side of the pump, and use those pressures, convert them to feet ahead, and there's a process for doing that. And then what you do is you find out the system's actual operating total dynamic head, and you go take that and apply it to the pump's pump curve. So hypothetically, let's say that we measured at 68 feet of head through that process. Go to the pump curve, look for 68. Now we're going to move across, intersect the pump curve, go straight down, and this system is actually operating at 60 gallons a minute, half of what that pump is capable of. We call it 120. So this is a very important step to verify and validate existing system compliance and safety, and how do we know, what is really going on. So before doing remodels, for example, replaster, that kind of a thing on public pools, very, very important when you're looking at it from a contractor's bidding point of view, is before that pool is drained, is find out what the maximum flow is. Turn off the skimmers, run the pump on high speed, measure TDH, or look at the flow meter and document what the actual flow is, especially if you don't know what's under the drain cover. If you don't know what pipe size is under the drain cover, step one before you drain the pool is collect this data, get it recorded. This is best practices, so take pictures You know, we all have digital cameras in our pocket now. We call them cell phones. So it's just, take pictures is my suggestion on that. So when we look at the process, one more time, wrapping this up, is just to reiterate, you want to know what are you dealing with? What's the size of the opening? Now you can get replacement covers like we saw in that retrofit where you could have a small opening with a bigger cover. Obviously it never works to use a smaller cover with a bigger opening, but step one, what are we dealing with in the pool? Step two, what is the pipe size and pipe depth in the pool? That will then give you those two things. The first two will give you what you need to go search in the marketplace to find an appropriate replacement cover. Then the third thing is to take that flow rating that you measured before draining the pool, and so now you have everything you need to select a drain cover. So sump opening, what's the pipe size, pipe depth, what is the system's actual flow rate. Those three elements need to be evaluated for every pump and every system. It's not just the filtration system, it's jet pumps. And watch those, because they don't have filters. They will often have bigger pipe so that the spa jets work well and feel good. So those TDHs will be lower and have higher flow rates, all things being equal. So it could be the same drain covers and the same pump, but because there's no filter and other equipment, heater and that kind of a thing, they're going to have a much higher flow rate. So that's really the key elements of compliance with the Virginia Graham Baker Pool and Spa Safety Act as it relates to suction outlet fitting assemblies. Thank you for listening. I hope you found this helpful, and have a great day.